Okay, now we'll have a discussion on introduction to interfaces. So in this session, we will discuss about what is an interface and why do we need interface concept in Java, and we will see how an interface can be implemented in Java programming. So we'll start with what is an interface. So interface is simply a collection of method declarations. So which means that whenever you simply have a method declaration, internally it is abstract in Java. So an interface is a collection of method declarations, you can say, or you can say it is a collection of abstract methods, right? Apart from the method declarations, you can have constants inside interface. So how do we create constant in Java? So if you want to create constant in Java, you go with the final keyword, right? So you can have variables, but these variables are by defaults or constants. So you can have constants inside an interface, and whenever you look at an interface, it is syntactically it looks similar to that of an abstract class, and an interface can have a set of abstract methods as well as final variables. And whenever inside a class, if you want to implement, if you want to apply, or if you want to create logic for all the methods of interface, then you have to implement it. So there is a keyword in implement in Java, so which allows you to implement all the properties, or which is going to inherit all the properties of an interface into a class, right? So if you want to inherit all the properties of a class, we'll go with an extends keyword, right? Likewise, if you want to inherit all the properties of an interface, we will go with implements keyword. So inside an interface, we will always define a set of abstract methods. So methods are internally behaviors of an object. So with the help of an interface, we are structurizing the behavior of an application, and based on the interface, the following classes should have the implementation for all the methods, and each and every method which are declared inside an interface, which are being implemented inside a class. So every class will have the implementation of the uh, methods which are available inside your interface. So this is a typical example of why do we need an interface, right? So here there are two classes. In the first class, we are calculating the salary of a US employee. In another class, we are calculating the salary of an Indian employee. Maybe both the employee maybe belongs to the same company. In that case, calculating calculation functionality may differ in each and every country, right? So for calculating the salary, you know about the employee ID, and what is an outcome. If you know the employee ID, then the particular employee will have some salary, right? So even though both are different classes, one class is going to calculate the salary of an employee, US employee. Another class is going to calculate the salary of an Indian employee. So both are unrelated classes, right? Because the implementation logic is going to be entirely different. So in US salary calculation, you have to follow different track or different methodology. For Indian salary calculation, you have to follow the norms of the Indian government, right? So both are independent classes, but still there is a common behavior, right? So what is a common behavior between these two classes? Calculating their salary. So in that case, interface should be the parent class for both the classes, right? So here we will create an interface which is going to be the parent, and both the classes should implement the interface so that it can have their own implementation for the calculate salary method. So what is the purpose of an interface? So interface, with the help of an interface, you can have a common behaviors in different classes that are not related with each other, right? So this is an idea behind interface. Whenever you have a classes which are unrelated, then for if they have some common behavior, then you can have parent as an interface. right? So inside a interface will only describe the behaviors that are not specific to any object but common to several kind of objects. So here we are talking about objects, right? So internally, interface covers, and in the interface it is going to merge unrelated objects together. Okay, why interfaces are required? So there are different strategies are there in applying interface in Java. So you can group several independent classes together with the help of an interface, and it also reduces the coupling between unrelated classes inside your application. So that is a major idea behind interface. Apart from that, in Java, the Java does not support multiple inheritance concept. So multiple inheritance in the sense a class can have more than one parent. So literally it is not supported in Java, but with the help of an interface, you can achieve or you can create multiple inheritance in Java. So which means that a class can implement more than one interface. So likewise, you can have an multiple inheritance structure with the help of an interface. And this is a key point you should remember. So whenever you create or whenever you have a method declaration inside your interface, it is by default it is public and it is abstract. And whenever you create a variable inside interface, which is always public, static, and final. So these two things you have to remember regarding interface. So here I have shown three different pictures. So but apart in these three pictures there is a common behavior, right? That is fly. So all the three objects can fly, right? So but both the three objects are unrelated to each other, right? But they have a common behavior, fly. So in that case, so in real time, so if you want to group or if you want to create a hierarchy of unrelated classes together, then you can create the common behavior inside your interface as a parent. So here you should not go with an abstract class. Why? In abstract class is always meant for grouping related classes together, and interface is always meant for grouping unrelated classes together. So this is how we create interface in Java. So there is a keyword interface. Here I'm going with a public modifier, then interface name. Then inside interface you can have a declarations. I have a declaration for add method. I have a declaration for division method, and I have a declaration for display. Then I have two variables. By default, these two variables are treated as final. So I should assign some value for it. And these three methods by default are assigned as public as well as abstract. And if you want to inherit the properties of an interface inside a class, then you should go with the implements keyword. So implements your interface name. So whenever you implement an interface in a class, may ensure that you are you are implementing all the behaviors of a particular interface. So here we have inside first interface we have three methods. So inside your class you should implement all the methods, right? So here I'm defining add method, I'm defining division method, I'm defining display method, right? So what will happen if you fail to implement any one of the method, right? In that case your class will become an abstract class, because you have one or more abstract method inside your class. Then this class should be treated as an abstract class if you are not implementing any one of the method of an interface. Suppose if you are implementing all the methods of an interface, then the class can be actual class, otherwise it should be abstract class. So this code will throw compile time error. Why? So here we have an interface with the two members. One is a private member, one is a protected member. Both I am private member declared A as 100. For protected member I have a method m1. Here I am implementing interface and I am defining method for I'm writing logic for m1. I'm trying to compile it, right? So what is wrong with the code? So by default all the member variables are public and static and final, so you cannot have any private variables inside interface. Likewise, the methods are by default public, so you cannot have any other modifier for the method. So that is why you are getting compile time error over here. And here, what is wrong with that? So here I have a static int a, so this is allowed. It what about static void m1 of? So in that case, whenever you declare a method as a static, ensure that you are defining the actual logic for the method, because static method are always belongs to the class, and static method should always have method implementations, right? But if you are declaring it inside an abstract inside an interface, then it should be abstract method. So static methods cannot be abstract, so you cannot declare a static method inside an interface. So that is why you are getting compile time error, right? So so while applying interface, whenever you develop a project, or whenever you develop a software, there are frequent changes may happen throughout the development time. So interface can support these set of changes. So in the initial stage, you may have certain common behaviors, and later sometime you may be adding some additional common behaviors. So everything is supported in interface. So this will makes your application or more reusable, extensible, and maintainable with the help of an interface. And so this is how we create a simple class with an interface. So here I have an interface with a display method, and here I'm implementing the implementing the interface in the demo. And here I have this add method it is specific to class 1, and the display method, this is an implemented method which I have taken it from my interface. So this is how we apply interfaces in Java. And here I'm taking another class, implementing the same interface with the multiplication method, and inside display I'm displaying welcome to Java. And here I'm creating an object for both the classes C1, and I'm invoking corresponding methods. So whenever you wanted to implement a particular interface, ensure that you are implementing the methods of the corresponding interface. So apart from that, it is possible that you can create reference variable for you can have a reference variable for your interface. Yeah, so as you know that you can create an object for an actual class, but for an abstract class you are allowed to create only references. Likewise, interface, you cannot create you are not supposed to create an object. You can have references for an interface, right? So with the help of an interface references, you can achieve runtime polymorphism as we have done it in abstract classes. And here I have another demonstration of demo. So here I have an integer demo with the display method. I'm implementing the interface inside a class 1, and here I'm implementing inside a class 2. But inside the main, here I'm creating a reference for the interface. So interface demo C1 equal to new class 1. So this is a parent, right? So this is a parent. Here I'm going to hold the child object. So in that case, C1.display invokes the method implementation which is part of class 1, and here C1.display which is going to invoke the corresponding display method implementation of class 2. So you can also have an interface reference, and you can invoke the corresponding method of a particular class. So this is also a typical example for runtime polymorphism. And apart from that, if you want, you can extend an interface from another interface. So here, with the purpose, you should go with extends. So in that case, an interface can extend all the properties of another interface, right? So here we will see how to do that. So like a class can extend another class, similar to that of you can create an interface which is going to extend all the properties of another interface also. So that is also allowed in Java, extending an interface. Then there is a special type of interfaces which we call it as marker interface. So the marker interface practically it does not have any method declaration, or it does not have any abstract method inside it, but these marker interface carry some specific information to the compiler or interpreter. So we call it as a marker. For example, there is a interface clonable, so which allows that, which states that The particular class object can be clonable and serializable, which we'll discuss it later. So serializable allows an object of a particular class is serializable. So in that case, you can write an object into one corresponding file. And so remote allows the particular object can be accessed in the remote method invocation manner. So these are all the marker interfaces which apply some specific information to your compiler as well as interpreter. If you implement this interface, you don't need to implement any other methods inside your class. So what is wrong with the code? So here we are creating an interface, and with a variable a equal to 100 with the method void m1. Here I am using the keyword extends, right? So it is a class, but whenever inside a class you have to use the keyword implements. So here I should not use extend. So here I should use the keyword implements, right? So here to throw compile time error. Why? Because we are creating interface I1 with one member variable and one method, and here I'm going to create another interface with the keyword implements, right? So here the implements keyword should not be used, because implements keyword allows you to implement all the properties of a method inside a class, right? But in case of interface A1, you should go with an keyword extends. So an interface can extend all the properties of another interface, right? So here we have two interfaces I1 and A1. So here A1 extends I1. So this is allowed it because an interface can extend or inherit other interfaces. And for the class implements I1, so you have to implement all the methods of an I1. So here I'm implementing method M1. So this is a valid. So this code will get compiled successfully. So this is a common difference between abstract class as well as interfaces. So inside abstract class, if you wish, you can have non-final or non-static variable, but inside interface, it is always static and final. And inside an abstract class, if you wish, you can have concrete methods, but in interface, you cannot have concrete method. But for your kind information, after JDK 1.8, it is possible to have concrete methods inside interface, uh, and inside an abstract class you can have a different kind of access modifier, but in inside interface only public is allowed, uh, and moreover the methods cannot be static. Here you can have static methods. And abstract, if you want to extend an abstract class, you can go with extends, but an interface is being implemented up by a class with the help of an implements keyword, and abstract class can extend another class and it can implement one or more interfaces. So inside an abstract class you can have implement one or more interface, and but an interface cannot extend a particular class, right? And abstract class can have a constructor, but interface should not have any constructor. And you cannot instantiate abstract class as well as interface also cannot be instantiated. It means that you cannot able to create object for abstract class as well as interface. But if you have a main method inside your abstract class, you can still able to run the file, but apart from interface you cannot execute an interface. So far we discussed about working with interfaces, creating interface, how interfaces are implemented in Java. Then we discussed about uh, comparison of abstract class as well as interface in Java.